In this video, we'll go through dataset and data loaders as per this chapter here in PyTorch documentation. So datasets store the samples and their corresponding labels, and the data loader wraps an iterable around the dataset. Right. So when you see the word sample, it actually refers to a mini batch from the entire bigger data set, right? So every time someone refers to samples, they just mean it's a mini batch of data from a bigger data set that you're using for your training and testing. And then we have some references to PyTorch image, text, and audio datasets if we need to play around with that. And then let's get to loading the dataset. I'm just going to jump right into our code and then just look at how all that works. So what we're doing here is obviously doing the necessary imports and then training data. So we're getting fashion MNIST data. So we're defining a root directory, and download is true. So if the data is not in the, the data set is not in the root directory, it will go ahead and download it. Training is true because this is a training data, and transform to tensor is also to tensor. So let's look at this to tensor method and what it does. I think I may have this open already here. So it converts a Python image library image, so the object using the Python image library Python package or the NumPy array to tensor and scale the values accordingly. So basically it takes any image from PIL or an NumPy and then converts it into the tensor that we need. I'm not going to go into too detail here, but if you want to, then yeah, you can read about how Python image library stores the image and NumPy stores the image. So there's a slight variation which I get to learn on one of the Udemy course a while ago. But if you want to jump right into that, feel free to pause this video and explore that as well. And then what we have, let's go back to our code. Then we have same thing repeating for the test data. The only difference is the train is equals to false. Let's move to the second block of code here. We have labels map, basically it's a dictionary, and we have index key and then the value. So values are the label name and key are the indexes. And we have here matplotlib plot of 8x8, and we have column and rows 3x3. We can look at that in the data documentation here, why we're doing that. So we're sort of printing the data set like this to have some sort of view into it. And then we have, I'll just put the original code back here, but actually I'll leave this because we were going to just iterate over this once. So what we are doing here, let's go line by line. We're generating a random integer based on the length of the training data, and the size is 1, and we're getting that integer here. And then we are also getting, using that index, we're getting the training data, one item from the training data. And when we get a return on that, we get image and a label. So it returns a tuple, and the label being the keys here, and then the actual image, right? So then we add a subplot to this plot we created, 8x8 plot, and then we use the rows and columns and the range the number here, and then we're adding a title here using the labels map. So whatever the index is, it's getting the name like that. Pull over here, which is the second one. And then we're turning the axis off, meaning like there's no x and y axis displaying here. And then we're showing the image, and we are squeezing the image sequence, and and then we're showing the image in gray because these are the gray scale images of clothing. So what I'm going to do is quickly jump into this and show you what that means, right? So here, if we look at this tensor, right, what squeeze does is, I think I may have, So I'm gonna drop this to like 2 by 1 by 2 and then do the display. So let's start with 2 by 2 array, right? I wanna do this print f of x. We don't need the shape. We don't need the shape. So what the squeeze method does basically is it removes, if we have, it squeezes any dimension, any tensor with one dimension value, right? So if we look at this 2 by 2 array just for a demo, you can see there are 2 items and there's 2 items in one tensor and there are 2 tensors here, which is the 2 by 2. Now let's just add 1 in this and then do 2 by 1 by 2, right? So what we have is we have, I'm not gonna even say that, and just print the tensor itself again. So what we have is 2 tensors with 2 larger tensor with 1 tensor each and with 2 items in here, right? So when we call squeeze on this, what it does is it removes this one dimension, right? So if you look at this here, we have 1, 2, 3 braces, and on the third one we have 2 items and we have second item here. So if you look at the second one, it removed this one dimension by doing this squeeze method, and we just have 2 by 2 tensor, right? So that's what it does, the squeeze method. So we squeeze the image and we basically show the image here. So I'm just gonna put the original code back there on the range. I think we had, yeah, so we're multiplying, basically we are multiplying column and rows, so that's 9 plus 10, and we're getting 1 to 9 using this range method, right? So if we print that, we should get exactly like what's in the doc. So there we go, we've got shirt, dress, ankle boot, etc. And then let's go into this code here. This is currently in this chapter, it's not being used, but I guess this gives us a detailed idea of how the dataset works and how it fetches the images that we need, right? So we have the usual init method here, and we get annotation file, image directory, whether to transform the image and then transform the target as well. Target meaning the actual label. So for example, you have output coming in from neural network and you have a target. All right, so you want to transform the target image or not. Let's dive into this documentation again. There's some more explanation here. The init method runs once. We initialize directory containing the images, annotation file, and both transforms covered in detail in the next section. And then the length function, so we can just go here. It just gives us the length of image labels. And we have get item function here, which takes the index as a get item method, which takes the index as a argument. And then what it's doing here is using the directory, it's getting the image labels using this iloc, which is the pandas method, which I did not know about. So it just uses the index and the 0th column and gets the data from that. And we're just reading the image here and then label. So we again getting the image label from this column 1 of this image label we've stored, which is here, and we're using pandas to read this CSV, and we're getting all the data into this image labels, and that's how we're reading them here. Label, filter, target, transform. So here, if the transform was not none, then yeah, we're processing the transform. We will get to these what these transform mean in the next chapter in detail. So let's just continue right on for this. And let's go into this data loader section. So we're defining the train and test data loader. They're simply we're instantiating using the data loader class, providing training and test data and batches of 64 on both, and we're setting shuffle equals to true, meaning when the one iteration of shuffle training completes, it will shuffle the data before the next iteration begins. Then we have train features and train labels, right? So what does train features mean, right? So let's just jump back to this code again. So we have loaded the dataset data. We can iterate through dataset as needed. Each iteration below returns a train feature and train label containing 64 features and labels respectively, because we specified shuffle true. So we have 64 images to process, and then we have labels for them. So basically we use the label when against the neural network prediction to check if what we're guessing is correct or not. Now let's go back to this train features squeeze. So we're printing these sizes here, and then we are just getting an image from the feature, the first image and first label, and we're just displaying that here. Yeah, so there's not much here. So I guess that wraps up this chapter. There was not I mean, when I say there was not a lot in it, as in terms of like actually getting into neural networks, but still there's a lot to learn here. And I think I'm still not fully clear on like this section where we used matplotlib to get the data here. Where's the custom? So here we read from matplotlib, right? So using the annotation file, and then we extracted these labels, and then the label numbers and the label text from there. It would be interesting to see that. So let's see if we can dive into that here. So we have sample data, MNIST CSV. What's in the CSV? Let's take a look. Download. Or is there a train small? Maybe. No, I'm not getting any. Okay. Nice. See if that will kick in our download. No, I can't see the download. Let's see. Got anything on the... Nope. Can't see anything. All right, that's okay. I will figure this out. Raw. We have a bunch of ZZ here, ZZips. I'm just interested in knowing what's in this CSV. Okay, I think we're getting some test data now. So let me just open that up in PyTorch. So if I just go here and dump this CSV that we just downloaded, so it just obviously it's just a CSV with all the accuracy. So what I wanted was the annotation file. Let's just see if I can find that. Labels. Let's see if I can download this zip file. Takes a while to trigger this. Anyway, so I'm gonna wrap this video up now, and if I manage to, I will manage to get this file and to dive into this CSV and how it's reading all this, and then I can include that in the one of the whichever video I managed to get that on. But the next chapter is on transforms, so we will get to learn a little bit more about what happened during the transform to tensor method. So yeah, I'll catch up back with you on the next video.